All right, it is a half day. I think we're going to be done at 9:33. So let's go ahead and get right into it. Today you're basically just going to have a little bit of a reading section. I found a video that kind of helps a little bit show some of the wave demonstration and also something that might be helpful towards making something for the STEM night if that is something that we do have. I always look forward to like the STEM night, and we didn't get to have it last year, and it just is what it is. So in the materials, looking at Wednesday, you'll see this MWI, mechanical wave interactions, I believe, 2.3. So go ahead and open up that document. And then just as a quick explanation, basically you just have 3 definitions that you need to get from the reading. There's an additional like quick little example of what is a wave reflection. And if you want to like do a little bit extra, you can add a photo of just like a wave absorption, wave transmission, wave reflection. And then these questions on here, these like application or discussion questions, they're going to be basically, just kind of like open-ended. They're not really in the text per se. If we don't finish in time, it's not a big deal. We can just take this whole assignment from Wednesday and just block it right down to Thursday. Not a big deal. But there's really like not, it seems long, but there's really not a lot to it. So it's not bad. And if you kind of open up the McGraw-Hill on your own, you'll probably be able to kind of skim through this a little bit faster. So I will take these paragraphs, put them up, and I kind of scroll down slowly. Let me know in the public chat if you want me to scroll down a little bit faster. But I'll try to kind of maintain a pace for everybody. And if you're just a fast reader, then go ahead and open it up on your own and kind of read through it. I'm going to go ahead and mute myself and give you a little bit of time to read this on your own. Real quick on the public poll. Does me having the McGraw-Hill open in the public chat, is that helpful to you? Or is that something I don't need to really do? This reading right here. Is this helpful to you, or is it just kind of a waste of time? Okay. All right, so like I said, I will, it seems like it's helpful, so I'll keep doing it. I will mute myself, and then I'll just kind of scroll up slowly at a time. The first 2 answers are going to be just right here in this little section. And we haven't really done any of these labs, like, physically, so.
You are now muted. You are now unmuted.
Liam, if you look at the title of the document, it is 2.3, read about how waves interact with matter, waves of interaction with matter in McGraw-Hill. And if you look at the description of the assignment in Schoology, you will find that everything is the same. Sorry, that wasn't really... Sorry, that wasn't really fast. I got nervous talking fast in front of my wife. But yeah, come on, man. It's just right there. And it's just right there. And up there. Come on, is this your first day on the job? And then here's the last definition.
You are now muted. You are now unmuted.
Samir, are you done with the... If you're done with the definitions, make sure you do the application questions. If you're done with the application questions, then go ahead and watch this video and do the extension. So again, on the Google document, there's kind of 3 sections here. If anybody needs me to scroll up, scroll down for the definitions and so forth, just let me know. If anybody wants to be cool and help me, let me know who is absent.
You are now muted. You are now unmuted.
I believe Hema also. I'm not trying to like throw anybody under the bus. I'm just trying to... Oh, Hema, you're here. Okay. Sorry about that, Hema. At 9:17, I'm going to 9:17. I'm going to we'll do the reviews a little bit. He'll be right back. I'm going to close this door.
You are now muted. You are now unmuted.
Sorry, my kid's got a appointment with the Children's Hospital, so that's why I'm in this room instead of the other room. And they're loud. You don't necessarily have to do the extension. I think if you just like watch it and kind of like skip through it. Oh, I thought I was muted again. Yeah, it's 17. I'll talk for 3 minutes about the extension a little bit, and then we'll get into like going through this stuff. Real quick, before I start talking about the extension, do you need any of those definitions? So like transmissions there, absorptions there. Do you want me to like let it rest on any particular section? And if you do, just let me know like which word. This section has like 2, so yeah. So basically, and I may have told you this, and like particularly for like you, Izzy, even you, Liam, that weren't really here in 6th grade. We used to have this thing where it was like a STEM night, and basically what we do is we just like make stuff, kind of like a makerspace, kind of like a Pinterest or whatever, but we try to make it kind of like sciencey, engineering, STEMmy. I mean, we're a STEM school, so that's what we do. The last year that we did it, we had kids like making I don't want to say some of, but like some of them made like a lamp out of like cardboard with like different shapes, LED lights, batteries, and we have a bunch of different like cool stuff that we can do. Some people did pretty cool projects. They made these like little kind of like a cone, and you put it on top of a cell phone, and with a certain video playing, it'll actually cast like a 3-dimensional image. And they made actually like they made small versions. They gave away little samples of like the little tool that they used. It was just like an overhead thing that they cut. And then they made like a big one that we put on a tablet with like a butterfly, and you could actually like, they made like a box, and you would like, open it, and you could actually look down, and you would see like this 3-dimensional image based on the reflection of like a butterfly. It was super cool. We made, some people made like those dumb like little lava lamps, but other people made like some pretty cool. One project they made was like a maze, and you put a ping pong ball in, and you move it back and forth and side to side. So like it worked on a pivot point, and then you would try to like guide the ping pong ball through the maze. But the thing that was cool about it was on pegboard, so you could take the pieces out and move them in different places and like keep remaking the maze. Last year, Ross's brother, I don't even remember his name right now. He was going to help me make a a 3D AR sand table. Fahad, yeah. And I mean, he like knew how to do it and everything. Some of the dudes like Dr. Steady Fingers, Vicente, and that whole like Jedi crew, where we made all those stupid videos. Nathan Flores, Demonte was in there for a little bit. We were like so close to making a kind of like an arcade machine. We still have all this stuff. We just have to like cut the wood, and so it's just kind of like stuff like that. It's just kind of like stuff like that. So I thought one cool thing to make is and you gotta like ante up money. If you guys aren't doing anything to like make money, help out with chores, pick some weeds to your neighbors, old people's, if you have old people that are like neighbors and they like, they give away the big candy bars at Halloween, offer to like pick their weeds out or do some yard work if it's safe. You have a parent's permission, try to earn some money and we'll do some of these like kind of like cool projects. I can give you some supplies. I'm not even sure if we're going to do it, but if we did do it, it'd be pretty tight. But I thought like making one of these wave machines would be pretty cool. They don't take like a lot of money. They just take like a lot of like effort to like make it good. And that's going to be on that video. So I'm going to skip over these questions or these definitions. An example of a wave reflection. The answer to that is an echo. So right here, this example was like an echo. So the first question is to explain how an echo works. Echoes are like crazy, especially for like little kids. But how do echoes work? Who has that question? How do echoes work? And just based on the reading, I think it's actually in there, but how do echoes work? Even if you just had to like guess. Amin? Samir? How do you think an echo works? Skylar? Giancarlo? I mean, just simple. You don't need to copy and paste the big old Wikipedia definition. Ah, good job, Skylar. Good job, Skylar. Good job, Fernando. Yeah. Here, let me find those. Let me find those names. We need to GoFundMe for oh, it's alphabetized by last name now. So Belinda with 1,000 points. Which Fernando was that? That was both. Skylar down here. Was there one other person? Just you four? Okay. So, yeah, that's basically how an echo works. If you see like a wall or the side of a building, you can yell, and now your sound wave should travel and then bounce off. You can actually measure distance by an echo. If you multiply the speed of sound and how long it takes for that echo to get there and back, that's how far away the building is. You can roughly find out the time. Here, let's dust off this question. Why is it difficult? So think about absorption and think about transmission. Why is it difficult to hear someone in a different classroom? So if we are in the Mr. Glassman's room or my room, why is it difficult to hear somebody in the room next door? Why would it be difficult to hear somebody in like the social studies or the 7th grade side? Excellent, Demonte. Excellent. We're gonna have to have a GoFundMe for a few people. Belinda, maybe. No, Demonte's only got 3 points. But Belinda, she needs to get a chiropractor for her back carrying this class. Maybe Izzy too. She doesn't have a lot of points, but she does have a lot of answers. I don't even know where you are on this list. No, you got 1 point. I don't think these points really reflect effort. Although it's difficult to hear shouting from behind a closed door, why can you still hear sound? Right? Try using the, can you try to slide the word transmission? Okay, that's pretty good, Fernando. That's pretty good. Try sliding that word. That's weird. Both Fernandos always answer. Oh, that's why she's getting mixed up. Basically, it's kind of like the image, and you couldn't see the image if you were looking at my screen. But basically, if you think about a phone, you can hear the phone. If the door is insulated, as somebody else said, a lot of that sound is going to be stopped. There's some like window advertisements that say, you can get these windows that have this like gas, and the gas doesn't let sound because it's so insulated and so tight. But if you do have a door that's hollow, like my bedroom doors are just like they're just two. There's nothing in between them. They're just two sheets. If you punch a hole right through it, there's just going to be space between those two doors. It's not solid at all. They're cheap. Like $50 each. But sound can travel like straight through them, which is why I can hear the conference going on with the computer in the office from where I am at, because we have thin walls or hollow walls, and the sound transfers through the door. All right. If you want, we can still run through this again. We kind of like rushed through it a little bit. We can rush through this tomorrow. Don't worry about the extension, but I do want to take the last 5 minutes. I believe we're done at 9:33. I want to take the last 5 minutes to kind of look at this wave machine and just kind of look at some highlights, because I do think it's pretty interesting. Basically, this is somebody in another country talking about waves and how to protect like the city. Yeah, extensions are always just kind of like optional. I always want to make sure you have enough to do.
That are sitting behind them. So what we've got here today with the wave tank, we're going to demonstrate.
So this is what I'm interested in knowing, if you would want to make something like this.
Overtop the defenses.
Now this is like a professional one, so it's pretty high end.
See the different performance
But
levels of all of the
basically just using like a little bit of plexiglass and something that's like a little motor that will like push the water. That's all this really is. And the things that are right here, we can make those with the 3D printers.
And we're representing a storm surge. And this means that there's deeper water, bigger waves are going to be arriving at our coast.
They probably have one of these at like different science centers.
And what we saw is that
So basically,
even
this
though
is
the
just like a
waves
little
were
like
breaking,
model
there
machine
was still
that
enough
shows you
energy for
how
them to roll up
waves
over the
work.
dunes, in this case fill up our reservoir. But in real life that would have meant that any houses or properties or communities behind the defence would have been completely flooded. And really, that isn't an acceptable situation.
And I mean, to be honest, this is like an advertisement for
Coastal engineers.
the work that these people are
Now,
trying to do.
Reset our tank, and now we can start testing some of our different defences. Now, if there's only a little bit of wave overtopping, we can usually get away with just a vertical wall. If it's small in nature, it can easily just be set behind the dunes like we've just done there, or even incorporate into some dunes, and then that will essentially just provide another Now we did get still some overtopping, but it was a lot less than before. And we'll have a look how much we've actually got. Now what we've got here, we'll call
So
that
now he's actually measuring
about 50 mil. And while it's only a little amount in our
theoretically
physical
in
tank,
this model
this could
how
easily
much
be, say, 50 litres per second in real life. This is
how
the sort of
effective
volume
each of
that will
them
start
are.
leading to some problems.
each
But still,
method.
now the first thing we have to think about is that the beach is going to be first. How is that small?
So now instead of an incline in a wall, he's just using a
Larger
flat
waves
wall.
coming in, that's because they weren't breaking on the beach. They've actually hit the wall under really impulsive conditions. Now, what we can do now is actually see how much wave overtopping happened and how much extra water that we've got. Now, by removing the beach, we've now got about, say, 70 mils of overtopping. Now, this is the exact same structural conditions, but we've just now got no wave breaking in front. Next defence, we're going against it. The waves are then going to be smaller when they hit our defence, and it's going to have a better performance. Right, now we'll run our 5 waves through the tank.
And notice he's using the exact
To
same
use a
amount.
recurve wall. Now, the beauty of this is it's not any higher or
He's
larger
using the
in the
exact
structure,
same
but it's got this unique shape.
scientific
And this unique shape allows the water to come
consistency.
up, actually get captured in here, and then shot back out to sea. And because of the nature of this, there's going to be less waves coming over the defence. Now, we can show this by simply removing our vertical wall and clipping in our recurve. And what we're going to do now is run our 5 waves again and see if there's any difference. And this time, what we've seen is the waves are actually getting shot back out to sea. There's probably the same amount of wave energy going up, but it's all returning out. So in terms of our safety and the inundation behind the defences, it's a lot better. And in fact, there was no water that actually came over at all. So something defence. I've got that locked in, and we'll run our 5 waves.
Jeez, okay. I thought it was 33, but is this something real quick before you like
Now, there was still a lot of overtopping.
scattle off?
And that's because
Is
we've
this
still got
something
that
that you
same
want to like
gradient, that same slope that's
look
letting
at
the
a little
waves
bit more in
run up and hit
depth
the
and like
structure
look
with a
at, or
little
it's
more power.
kind of just like nah, let's move on? Yes, if you'd like to look at it in depth, no, if you want to move on.
So this time, we see that we've got about 100 mils.
It's not that big of a deal.
So it's actually less than the slope of that.
Yeah, it is. It is like pretty cool. It's a little bit more subtle, but I would like. I think it'd be cool if like a group of like 5 people like made this. And it's really not that difficult to make. So, all right, everybody. Peace out. Take care. Thanks. You have a nice day.